Hello everyone. Today we are going to discuss about the topic family of salts, that is types of salts. So different types of salts and their properties we are going to study today. So types of salts means for now different types of chloride salts, different types of sodium salts, different types of sulfate salts, different types of what here halide, sulfate, carbonate, different types of salts we can take. We can also say potassium salt, sodium salt, magnesium salt. So based on cation or based on anion, we can classify different types of salts. So write the formula of the following salts. First thing, what is that? Activity 14 is what? From your previous knowledge, you have to write what? Different formula of the following salts. Okay. So suppose first one, what is that given? Potassium sulfate is given. What is that given? Potassium sulfate. Potassium sulfate formula what? K2SO4. K2SO4. Potassium sulfate. Right now. So like that, if you take what next one? Sodium sulfate. Sodium sulfate Na2SO4. Na2. Please hold one pen and notebook. Take one notebook and pen, and please note down if you don't know the formula. I will be telling you formula of each and every salt. If you do not know, please note down. Potassium sulfate, K2SO4. Sodium sulfate, Na2SO4. Calcium sulfate, CaSO4. Ca plus 2, SO4 minus 2. Next, magnesium sulfate, MgSO4. Mg plus 2, SO4 minus 2. Copper sulfate, CuSO4. Cu plus 2 ion, SO4 minus 2 ion. Sodium chloride, NaCl. Sodium chloride, NaCl. Sodium nitrate, NaNO3. Sodium carbonate, Na2CO3. Sodium carbonate is what? Na2CO3. Okay. So next one is what? Ammonium chloride. Ammonium chloride is what? Ammonium chloride. Ammonium chloride is NH4Cl. NH4Cl. Okay. So like that, different types of salts. Once again, go through all those. Okay, ma. So it's about what now? Different types of salts. Different types of salts. Now tell me, in this, how many sulfate salts there? Sulfate. Here it is sulfate family. Okay. This one also sulfate family. This one sulfate family. This one sulfate family. Okay. Next here also copper sulfate family. So how many types of sulfate salts here? 1, 2, 3, 4, 5 salts there. Sulfate family. And how many potassium salts here? Potassium salts how many? Only one potassium. How many sodium salts here? Here in this case, here one sodium salt is there. Okay. And here sodium nitrate, sodium salt it is, and sodium carbonate, sodium salt. So sodium salts how many there here? And sodium chloride also is there here. Sodium chloride also what? Salt. So sodium chloride, sodium nitrate, sodium carbonate, okay, and sodium sulfate. These are different types of sodium salts. In this way, we can divide what? Different types of salts here. And how many chloride salts in this? Check it. See here, one chloride salt here, one chloride salt here, another chloride salt. So chloride salts, how many in this? 2. So we can classify all the salts into different types of families. Different families means different types. Okay. Next, identify the acids and bases in which, from which the above salts are obtained. From which acids and bases the above salts are formed, we have to check it. Now once again, go to the previous case. Here, potassium sulfate. In this, potassium is what? K. K is what? From KOH. K is from what? KOH, potassium hydroxide base. And sulfate means what? SO4. SO4 is coming from which acid? SO4 minus 2 will come from which acid? Sulfuric acid. H2SO4, no? So H2SO4, from that H2SO4, sulfate ion will come. So this salt, we have K plus from potassium hydroxide. SO4 minus 2 from sulfuric acid. So potassium sulfate is the salt of potassium hydroxide base, sulfuric acid, H2SO4 acid. So this potassium sulfate is coming from KOH base, means strong base. KOH is strong base, and sulfuric acid is strong acid. So this salt is coming from strong base KOH, strong acid H2SO4. Strong acid H2SO4. That means what here? It is the salt of potassium sulfate is the salt of strong base, strong acid. Strong base, strong acid. That point we have to keep in mind. So it is the salt of what? Strong base and strong acid. If you dissolve this potassium sulfate in water, we get neutral solution. Potassium sulfate salt in water will give some solution. That solution will have neutral nature. Why? This salt is coming from strong base KOH, strong acid H2SO4. If the salt of strong acid and strong base is dissolved in water, the solution will get which nature? Neutral nature. Neutral solution means what will be pH? Exactly 7. pH will be exactly 7. So neutral solution will be formed by the salt. Now imagine you take one here, suppose sodium nitrate. Sodium nitrate is coming from what? Sodium hydroxide base. Nitrate is from nitric acid. NO3 minus ion is from nitric acid. Sodium Na plus ion from sodium hydroxide. Sodium hydroxide is strong base and nitrate ion is HNO3. Nitric acid is strong acid. So again, sodium nitrate is the salt of strong base and strong acid. Therefore, it is also neutral solution. The solution of sodium nitrate also, aqueous solution of sodium nitrate also neutral in nature. pH will be exactly 7. Is that clear? Now imagine here magnesium sulfate. Magnesium sulfate salt. This MgSO4, magnesium sulfate, here Mg plus 2 is coming from where? Which base? From MgOH taken twice. MgOH taken twice is what here? MgOH taken twice is weak base, remember. Magnesium hydroxide is weak base. From magnesium hydroxide weak base, we got this one, Mg plus 2. And SO4 minus 2 comes from sulfuric acid. SO4 sulfate ion will be coming from sulfuric acid. Sulfuric acid is strong acid. Magnesium hydroxide is weak base. So magnesium sulfate is the salt of what and what? Weak base and strong acid. Which one is stronger here? Acid is stronger than the base. That's why the solution will be acidic in nature, basic in nature. The solution formed will be acidic in nature because magnesium sulfate is the salt of weak base but strong acid. So it is coming from strong acid and weak base. Therefore, the solution of MgSO4 solution in water will be having which nature? Acidic nature. Acidic nature means what will be pH? Less than 7. pH will be less than 7. Is the concept clear now? Magnesium sulfate, MgSO4. Magnesium sulfate solution will be in which color? Which nature? It will be having neutral or acidic nature. It will be having acidic nature. So is the concept clear now? So it's about what now here? Acidic nature and basic nature of the salt we can say. Acidic nature and basic nature we can say. Is that clear? So it's about what now here? It's about what now here? Magnesium sulfate. Okay. Next one, copper sulfate. So copper sulfate means what here? Copper sulfate CuSO4. Now this copper sulfate is formed by the combination of what? Copper hydroxide weak base and sulfate ion from strong acid. Sulfate ion is from sulfuric acid. Copper ion from weak base. So it is the salt of what? Copper sulfate is the salt of what? Weak base but strong acid. Weak base, strong acid. So here it is salt of what now here? WB. WB means what? Weak base is it. WB means what here? Weak base plus what? Plus which acid it is? SO4 minus 2 sulfate ion is coming from sulfuric acid now. Sulfuric acid is what? Strong acid. So here SA. SA means what here? Strong acid. So strong acid plus weak base. So this copper sulfate is coming from weak base, copper hydroxide, and strong acid, sulfuric acid. So copper sulfate, we can say it is the salt of weak base and strong acid. So what you have to understand, one concept is that always the cation of salt, positive ion of salt will be from base. That's why this cation is called basic radical. Basic radical. Basic radical means cation. And anion, negative ion of any salt will be coming from acid. The negative ion is coming from acid. That's why here negative ion, anion is called what? Acidic radical. Anion is called acidic radical. Cation is called basic radical. So here this basic radical K plus is coming from strong base, and this acidic radical SO4 minus 2 anion is coming from strong acid. So it is a salt of strong base, strong acid. Therefore, neutral solution will be formed when you dissolve this salt in water. Okay. So next case is what now here? In this case, copper sulfate. Copper sulfate is what now here? Salt of weak base and strong acid. So in this condition, in this condition what now? So it is the salt of weak base and strong acid. Weak base and strong acid. So in this case, now what we have to understand is that, okay, when you dissolve this copper sulfate in water, we get some solution. That solution will be having which nature? This strong acid nature, not weak base nature. So acidic nature will be there for this salt. Acidic nature means what will be the pH? Less than 7 or more than 7? Less than 7 will be there. Sodium chloride, you can understand. NaCl. Na plus is from NaOH, strong base. Cl minus is from strong acid HCl. So it is the sodium chloride NaCl is the salt of what? Strong base, strong acid. Therefore, again, neutral solution will be there here. Neutral solution. Okay. So this way we have to understand concept. Again, ammonium chloride NH4Cl. NH4 plus cation. Cl minus anion here. So ammonium chloride is the salt of weak base. Ammonium hydroxide weak base. But strong acid. Strong acid. So in this way we have to understand what concept here. Okay. So once again, please go through that once thoroughly. Yeah, gone through all the salts, different types of salts. Now next point what they are asking is that, not going next. So what they are saying here, identify the acids and bases from which the above salts are obtained. From which acid, which base the above salts are obtained, we have to understand. Next, salts having the same positive or negative radicals belong to same family. Okay, belong to what now here? Belong to a family, suppose. That means for salts having the same positive or negative radicals belong to same family. That means what? Suppose NaCl, NaNO3. NaCl, NaNO3. Both belong to sodium salts, sodium family. NaCl has Na plus positive ion. NaNO3 also has Na plus positive ion. So in both cases, Na plus is there. So which salt we have to say? Sodium family we have to say. Like that, for example, what is given? NaCl and Na2SO4. Both have same common Na plus. Na plus is common both cases. Cation is common. So these two are called what now? Sodium salts. So they belong to sodium family. So they belong to the family of sodium salts. Similarly, these two. In these two, what is common here? Cl is common. Cl is common. So as Cl is common here, anion is common. These two salts belong to which family? Chloride salts family. Salt family of chloride salts. So how many families can you identify among the salts given above? Above, sulfate family is there, chloride family is there, sodium family, like this. Okay. Next, pH of salts. Whether pH is less than 7 for the aqueous solution, pH is more than 7, or pH is equal to 7, we have to say. Okay. Collect the salt sample. Okay, like sodium chloride. Okay, sodium chloride we have taken and aluminum chloride we have taken. Sodium chloride formula what? NaCl. And aluminum chloride formula what? AlCl3. AlCl3. And copper sulfate formula CuSO4. And sodium acetate, CH3COONa. CH3, write down this one formula. Sodium acetate formula is what? CH3COONa. Because acetic acid we know, acetic acid formula what? CH3COOH. CH3COOH. In that CH3COO minus ion is called acetate ion. So sodium acetate formula what? CH3COONa. And ammonium chloride, NH4Cl. NH4Cl. Next, sodium hydrogen carbonate. One salt. Sodium Na, hydrogen means H, and carbonate CO3. So hydrogen carbonate means HCO3. So sodium hydrogen carbonate is also called sodium bicarbonate. Bi. Sodium bicarbonate or sodium hydrogen carbonate. Both are same. Sodium bicarbonate or what? Sodium hydrogen carbonate. Both will be same. Is that clear, ma'am? So in this way, what we have to understand now here? Sodium salts, potassium salts, next aluminum salts, like this different families we have. Now these all salts we are dissolving in water. Separately, each salt is dissolved in water, distilled water. Distilled water means pure water without any impurities. So in the water, when you dissolve these above salts, we get some solution, salt solution. That salt solution formed, whether it is having pH value more than 7, less than 7 or equal to 7. That one we have to say. That is called pH of salts. Actually, it is called pH of aqueous solution of salts. pH of aqueous solution of salts we have to say. Now next thing is that take the action of the solutions with litmus paper. Now if you take blue litmus paper will turn into red by the acidic solution, and red litmus paper will turn into blue by the basic solution. Like that we have to check the nature of solution. Okay, and find the pH using pH paper. Means universal indicator we have to take. Universal indicator, I told you colors. VIBGYOR, VIBGYOR, VIBGYOR colors. V, violet for what? pH value 13. And green, color green is for pH value 7. Color red will be for pH value 1. Let us approximate pH value we can find out using pH paper of universal indicator. Universal indicator is a mixture of what? Different indicators, several indicators. Classify them into acid, basic and neutral salts. Acidic salts, basic salts and neutral salts we have to divide here. In the given list, which salts are giving acidic solution, which salts are producing basic solution, which salts are producing neutral solution. That one we have to say. Okay? And identify the acid and base used to form the above salts. Identify the acid and base used to form the above salt. Suppose ammonium chloride is there. Ammonium chloride, NH4Cl. NH4Cl is obtained from which base? From NH4OH. From NH4OH base we got NH plus. And Cl minus we got from which acid? From HCl acid. HCl means hydrochloric acid. So NH4Cl is obtained from NH4OH weak base, HCl strong acid. Like that, the NH4Cl is the salt of weak base and strong acid. Therefore, its solution, aqueous solution will be having which nature? Acidic nature. Because the NH4Cl is coming from strong acid but weak base. Therefore, acidic solution will be formed. So the acidic solution means what will be pH? Less than 7. pH will be less than 7. So in this table we have to write the given salt and what will be approximate pH, what will be nature, acidic nature or basic nature or neutral nature, we have to write. Okay, suppose you take NaCl here, the first salt I am taking here, NaCl. What is NaCl? Sodium chloride. So the sodium chloride salt is obtained from which base and which acid? Tell me. First identify cation and anion. Cation and anion. This Na plus is coming from which base? Strong base. NaOH, na? NaOH is what? Strong base. NaOH is strong base. So NaOH strong base, it is coming, Na plus. Now Cl minus is coming from which acid? Cl minus comes from which acid? HCl. So HCl is what? Strong acid. HCl is what? Strong acid. So it is what? Strong acid. So HCl is strong acid. NaOH is strong base. So from strong base, Na plus is coming. From strong acid, Cl minus is coming. So both strong base, strong acid. That's why this solution, NaCl solution, will be neutral. Neutral means it is neutralized. So this NaCl solution neutral. So you write here dash and dash. Not applicable, not applicable. It is neutral solution. And what will be pH for the NaCl solution exactly? 7 it is. Why pH value 7 here? The pH is 7 because it is neutral solution. NaCl salt solution is neutral. Therefore, what will be pH value? 7 exactly. So pH will be 7. Neutral solution will be obtained here by NaCl. Like this, every salt we have to write here. 2-3 salts you can take and write pH value approximately, acidic nature or basic nature or neutral nature for the aqueous solutions we have to write. And salts of a strong acid and strong base are neutral. So this point is important. So what we have to write this point? Salts of strong acid and strong base are what? Neutral. Neutral means pH value will be 7 and the pH value is what? 7. pH value is 7 for that salts. Next, the salts of strong acid and weak base. What is strong here? Acid is strong. What is weak here? Base is weak. This type of solutions will be having which nature? Strong acidic nature. So whatever is strong, that nature will be there for this solution. So base is weak here, acid is strong here. That's why this type of salts of strong acid and weak base will be having which nature? Acidic nature, and the pH value will be less than what? 7. For acidic solutions, pH value will be less than 7. And the salts of strong base and weak acid. What is weaker here? Acid is weak. What is strong here? Base is strong. That's why this type of salts will produce basic solution. The solution obtained is basic in nature. Basic in nature means what will be pH? pH value is more than 7. More than 7. So in this way, pH is less than 7 or more than 7 or exactly equal to 7 we have to write. Next, what do you say about salts of the weak acids and weak bases? In this case, very important consideration. What do you say about salts of weak acid and weak base? Both are weak. Both are weak. Okay. In such cases, the pH depends on the relative strength of acids. The relative strength of the acid and base. The relative strength of the acid and base will decide what? Decide what? The acidic nature or basic nature. That means what? If the relative strength of acid is more than relative strength of base. If relative strength of acid is more than base, the solution will be acidic. If relative strength of base is more than acid, the solution will be basic in nature. If both weak acid and weak base have same strength, the acidic strength of this one and basic strength of this one, both are same exactly, suppose. In that case, neutral solution will be formed. Neutral solution will be formed. So in which case it will be acidic is that? So here, if Ka value, if Ka means what now here? The strength of acid is measured in Ka and strength of base will be measured in terms of Kb, remember. So about this you will study in higher classes. First remember that Ka and Kb. So relative strength of acid is given by Ka, relative strength of base will be given by Kb. Okay, ma? So suppose here if Ka value greater than Kb, if Ka value of weak acid is greater, than Kb value of weak base, suppose. If Ka value of weak acid is greater than Kb value of weak base, what will be nature of solution? Tell me. The nature of solution will be acidic or basic? It will be acidic. Why acidic nature? The relative strength of this acid is more here. The relative strength of acid is more. So it is acidic in nature. Why it is acidic in nature here? because Ka value is greater here. Ka value is greater than Kb value. When Ka value is greater than Kb value, the relative strength of acid is more than that of base. In this case, the solution will be acidic. When solution is acidic, what will be pH? Less than 7 or more than 7? Less than 7. Suppose if Kb is greater, if Kb of base is greater than Ka, Kb of weak base is greater than Ka value of weak acid. In that case, the solution will be basic. If Ka value equals to Kb, if Ka is equal to Kb, the solution will be neutral. In this way, the relative strength of acids and bases will decide what? The approximate pH of these solutions. So the salts of what? The salts of weak acids and weak bases. Okay, ma'am? So this Ka is called dissociation constant of acid. Dissociation constant of acid. Please be ready always with one notebook and pen. Whenever anything is important to write, you must be writing like running notes. Okay. So what is Ka here? Dissociation constant of acid. Otherwise, we can say ionization constant of acid. Dissociation constant of acid we can say, or ionization constant of acid. And what is Kb here? Dissociation, otherwise ionization constant of base. Dissociation or ionization constant of base is Kb. Dissociation or ionization constant of acid is what? Ka. If Ka value greater than Kb, the solution is acidic. If Kb is greater than Ka, the solution will be basic. If Ka is equal to Kb, the solution will be neutral. Is that clear? Next, chemicals from common salt. From common salt, which type of chemicals can be obtained? That is very important topic of this lesson. The salts are ionic compounds. Generally, salts are what? Ionic compounds are covalent compounds. Ionic compounds. Between cation of salt and anion of salt, which type of chemical bond exists? Ionic bond exists. Ionic bond is also called electrovalent bond. Electrovalent bond or ionic bond, both will be same. So salts are the ionic compounds which are produced by the neutralization of what? Acid and base. The reaction between acid and base is called what? Neutralization. Okay. Next, salts are electrically neutral. Most of the salts are what? Electrically neutral. Okay. So the total charge will be zero. Meaning, what does it mean here? This point is what? Salts are electrically neutral means the total positive charge of cations will be equal to the total negative charge of anions. The total positive charge of cation must be equal to total negative charge of the anion. Therefore, the total charge of the salt molecule will be zero. That's why we say salts are electrically neutral. They are not charged particles. There are number of salts. Okay, there are number of salts, but sodium chloride is the most common salt among them. Most commonly used salt among all the salts is what? Sodium chloride. So it is what? Common salt. Why it is called common salt? The most common salt among all the salts is what? Sodium chloride. So it is called sodium chloride. It is called common salt. Okay. Now sodium chloride is also known as table salt. Table salt basically. Why it is called table salt? As we use the salt in case of what? Now cooking. So in almost all items we use what? Table salt. So this is called table salt as we use for cooking, and common salt as it is most common salt among all the salts. And sodium chloride is used to enhance the taste of the food. To increase, enhance means what here? To increase. To increase the taste of the food, we use what? Sodium chloride, common salt. Okay. So it is about what now here? The importance of common salt. And seawater. Seawater means the water of ocean. The seawater contains many salts dissolved in it. Many salts will be dissolved in seawater. Sodium chloride. Sodium chloride is the predominant component, and it is separated from the salts. From many salts dissolved in seawater, we can separate what here? NaCl, because NaCl is most common salt. As it is most common salt, we need it. So we extract the sodium chloride from different salts of this seawater. Deposits of solid salt are also found in several parts of the world. Okay, so generally in our daily life, you can ask your mother or father about what two types of salts will be there. Rock salt will be there, and common salt will be there. Okay, suppose Annapurna salt is there, Tata salt is there. The Tata salt is nothing but common salt. That is NaCl obtained from seawater. But the rock salt in Telugu called Saindhava Lavanam means rock salt. That rock salt will be obtained from the layers of the earth crust. From the earth crust, we dig out the rock salt. The rock salt will be in the layers of the earth crust. Okay, from the earth crust we get what? The rock salt. But the common salt is obtained from seawater. So deposits of solid NaCl salt are also found in several parts of the world. So these deposits of large crystals are often brown due to impurities. If you buy the rock salt packet, it will not be white in color like NaCl. Like common salt, the rock salt will not be in pure white color. It will be having brown color. The brown color of this rock salt is due to what? Some impurities. Due to some impurities. Remember. This is called what now? Rock salt. What is this called? Rock salt. Okay. Beds of rock salt were formed, okay, when seas of bygone ages dried up. Suppose in olden days some sea was there. In one area, suppose you take example of Dwaraka. There was one city called Dwaraka of Lord Krishna, nearby Delhi. The Dwaraka city completely is underwater now. Initially, there was no sea there. Now it has been covered by sea completely, the city. In the same way, in olden days, in some areas, some sea was there, suppose. Now it is not there. That means the sea water completely dried up. The sea water in that area completely dried up. Bygone ages means what? In the past age. In the past, some sea was there. The sea water completely dried up. Then what will be forming? The beds of rock salt. Beds means what? The layers. Beds of rock salt meaning what here? Different layers of rock salt were formed when seas of bygone ages, the past ages, dried up. When the sea is getting dried up, in that area, what will be there? Different layers of the rock salt were formed. Okay, the rock salt is mined like coal. Do you know how coal is extracted from the ground? From the earth, the coal is mined. Coal mines will be there. Coal mine in Mangur area, in Kottagodam area, we have coal mines. We dig the crust of the earth and we take what? We mine what? Coal. We extract the coal from the earth crust. In the same way, the rock salt also is mined like coal. Means it also will be extracted from the earth crust. So this is about what now here, introduction of the important compounds that can be obtained from common salt. From common salt, NaCl, we can get many substances that we use in our day-to-day life. Is that clear, ma? So it's about what now here today's topic. Okay. So are you all following everything? Yes, I'm muting you all. Yeah, anybody can talk to me now. You can talk to me. Are you all following the textbook lessons?
Yes, sir.
Yeah, please read the same lesson the same day. Whatever I teach, I am teaching exactly whatever is there in your textbook only. Exactly whatever is there in your textbook, point to point. Every word I am explaining. Please go through that point to point, everything, so that you will get very good marks in state board first. After completion of state board, again we will go to IIT. Okay, and state board is also very important. From state board also sometimes some important bits will be asked. IIT is not separate from state board. Remember, state board syllabus also is the part of IIT syllabus. It is also one of the parts of what? IIT syllabus. Don't underestimate the power of what? State syllabus. Okay, state syllabus science, state syllabus mathematics will be useful for even IIT. Remember, IIT, MSET, in many cases that bits will be asked in different competitive examinations. Is that clear, ma? Please read the textbook lesson point to point every lesson, whatever we have finished. Chemical equations we have completed. Next we are going through now this one. What is this? Acids, bases and salts. This lesson also is important. In one more class, the lesson will be finished. Okay, ma. Bye. Good day.